The idea for this tutorial has yet again sprung from a subscriber's question. How do you animate a propeller on a plane or a rotor on a helicopter? The question was actually more elaborate than that, as the user needed to know how to control the animation, mainly how to vary the speed and not have the propeller necessarily spin at a constant velocity throughout the animation. You will explore different scenarios here, not only how to keyframe the 3D propeller, but later how to add motion blur effects. These are always important, especially for objects moving at high speeds. You will learn to create such effects using only 3ds Max or with the help of compositing software. As always, scene assets and support files are provided so that you can follow along. In this startup scene, you have a P-47 Thunderbolt World War II fighter plane. It is made of different parts: the main body, the canopy, the propeller, and the landing gear, including the tires. Although not the subject of interest in this particular case, the landing gear is retractable with the help of a custom attribute applied to the main body. Therefore, it will be easy to animate the landing gear should you decide to experiment with the scene. However, the subject of this tutorial is the propeller. Technically, this particular plane had a 4-bladed propeller in its time, but we'll deal with the 3-bladed propeller for this exercise. To animate a propeller at a constant speed, you wouldn't want to guess the number of revolutions it needs between the start and end of the animation. This would have many drawbacks. First off, the math itself is not very appealing to get into. Second, and most importantly, you may decide to change the timing of the animation at a later time, and this would mess up your original calculations. No, the trick is to induce a rotation angle for a number of frames, and then repeat that rotation for subsequent frames. Looping the animation this way makes it very easy to rotate the propeller at a constant speed, even if you decide to extend or shrink the animation. It also makes it easier to control that speed, making it spin faster or slower, simply by adjusting the original animation. You'll start by animating the propeller at a constant speed, and then move to learn about varying that speed later. Select the propeller in the scene and enable Rotate mode. Ensure Angle Snap is on, and set the coordinate system to local. Also make sure rotation is based on an object's pivot point. The local axis of interest in this case is the Z-axis. Enable Auto Key mode and go to frame 10. Rotate the propeller minus 120 degrees. Test the animation. At the moment, the propeller is only animated between frames 0 and 10. You need to loop this rotation for the length of the animation. Right-click the viewport and choose Curve Editor. The Z-rotation curve is displayed. Select the Z-rotation track to isolate that curve. To access looping functionality, you need to display the appropriate toolbar. Right-click an empty area of the Curve Editor's toolbar and choose Show Toolbars, Curve Track View. Again, make sure the correct track is selected, and then on the new toolbar, click the icon labeled Parameters Curve Out of Range Types. The name of the tool is a handful, but it provides you with various looping functionality. By default, you are in constant mode, meaning that the animation is only taking into account the timing between the first and last animation keys. You can choose other options, such as cycle, loop, ping pong, linear, and relative repeat. The last one is the one that interests us in this particular case. Try others, such as cycle or ping pong, to see the effect you get. Obviously, neither of these modes works in this particular case, as you need an additive effect. Try the relative repeat mode. Strangely enough, it looks a little odd, but that's because of the ease-in, ease-out tangents on the original keyframes. For this to work well, you need linear tangents to allow a fluid continuous motion. Select the two Z-rotation keyframes and set them to linear tangents. Play back the scene again. This time it works beautifully. The selection brackets make it look a little weird, but that's just an optical illusion. If you deselect the propeller and try again, you will see the effect is exactly what you planned. From that point on, to make the propeller spin faster or slower, but still at a constant speed, you can expand or reduce the timing between the two keyframes simply using the timeline. Set the keyframes between 0 and 10 and exit auto key mode before moving on. Save your file up to this point, as you will need it later to learn about motion blur. If you omit that, you can as always revert back to one of the files downloaded for this tutorial. Now let's take a look at how you can vary the speed to simulate an engine starting up, for example. You can always try to add more keyframes to the existing track, but a better method would be to use a multiplier curve. This way, you keep the current track untouched, knowing that it's working well. It's an easy way to layer your animation. In the curve editor, again, make sure the Z rotation track is selected and the curve displayed. From the Curves menu, choose Apply Multiplier Curve. Notice the plus sign next to the Z rotation track. Expand it and you'll see a new track added that affects the original. Select the multiplier curve track to look at it. For now, it is flat, with keyframes set to a value of 1. A multiplier value of 1, as in basic math, has no effect on the animation track to which it is applied. This means that the propeller still reacts as it did before. The trick is to edit this curve to slow the propeller using multiplier values between 0 and 1, or speed up the propeller using multiplier values higher than 1. You can even make the propeller spin backwards by using negative values, but we won't get into that here. For the time being, let's say we want the propeller to be static at the beginning, then start spinning slowly gathering speed, and finally kick into full speed. You'll need to add a couple more keyframes to the multiplier curve. To do that, use the Add Keys icon and click any 2 points on the flat curve. You will edit them in a second. Go back to Move Keys mode when done. Select the first 2 keyframes and set their values to 0. This will effectively kill the rotation of the propeller between these 2 keyframes. Select the second keyframe, or speed control point as it practically is, and set its timing to frame 20. This means the propeller remains static between frames 0 and 20. Select the third keyframe and set its timing to 70 with a value of about 0.5. You'll be able to experiment with these values in a moment. Select the last keyframe and set its timing to 80 and its value to 10. This means that by the time you reach frame 80, the propeller would be spinning 10 times as fast as what you started with. Play back the animation in the viewport. The propeller starts off static, then starts to spin slowly, and picks up speed towards the end of the animation. There are a few things to be mindful of. Scrub the animation slowly between frames 70 and 90. Between frames 70 and 90, the propeller seems to be spinning backwards at times, but that's normal when a propeller is spinning fast. Above frame 80, however, it appears to be static. It is actually rotating 120 degrees on every frame, making the 3 blades occupy each other's place on every subsequent frame. You can see it better if you set the timing to frames and ticks, in which case you will see the spinning effect. Another way is to slightly offset the animation. Go back to the Z rotation track in the curve editor. Select the second frame and set its rotation angle to -130 instead of -120. This prevents the blades from taking each other's place and induces an offset effect. Play back the animation again. Extend the animation to 200 frames to see the effect better. The effect seems convincing in the viewport, but if you were to render it now, you're in for a surprise. If anything, the propeller seems to go slower after the engine has kicked in. The problem is that the 130-degree rotation has the same effect as a 10-degree rotation. What you need is to add motion blur to give the propeller a sense of speed. This is what you experiment with in the next movie.